Welcome to another Cloud Native Short Take from RxM. My name is Chris Hanson, and today we're going to be reviewing the Kubernetes module Pod Scheduling. In this module, we typically cover things like the default scheduling process, selectors, affinities, even pod priorities and preemptions. Along the way, we do a number of demos. So today's demo will be covering pod anti-affinities. So let's get started. So I've got a 4-node cluster here that I've set up, and I've labeled the node. So I've already output all of the node labels, and we can see that my workers are 1 through 4, and I've added the zone label to each one of the nodes, where the odd workers are zone A and the even workers are zone B, and that's going to let us use that zone label in our anti-affinity. So let's take a look at that anti-affinity. So taking a look at our deployment here, focusing on the affinity section, we've got an anti-affinity that's got 2 expressions: required during scheduling and ignored during execution. It's a very long key, and yes, you must put that all in there because they wanted to make something clear, which is this is going to be used during scheduling, but at execution time, which means if the pod's already running, it doesn't get reevaluated. Scheduling is not dynamic, right? It happens one time, unless something else happens to the pod. So our label selector here uses the labels of the pod itself, right? So I've got app with the in operator and the value cnst schedule, and of course that's our labels for the deployment, our selector, and the pod template as well. So this is the one we are really concerned about, but just made them even all the way through. And so what this means is that using the topology key hostname, that no 2 pods should land on the same host, right? So we're making sure that in a scenario where we absolutely want to make sure that no 2 pods run on the same host, that that happens. And of course, the kubernetes.io hostname label is something that was pre-configured at install time. I didn't have to add that as an extra label, right? So if we go back here, we can see the hostname value is the same, of course, as the name of the node that I was using in my queries. The second part of this expression is preferred during scheduling, ignored during execution. And we're going to use the zone label to spread across the zones. Again, same expression, identical to the required during scheduling anti-affinity, but we use prefer, the difference being that required means that no 2 pods can end up on the same node because the scheduler uses a predicate matcher, and that predicate is a filter that removes the node from the scheduling loop. All right, so let's take a look at how this works in practice. What I'm going to do is switch to kind of a split view here where we can watch what happens as I issue commands. So I've already got a watch set up where we're going to get the deployments and the pods in my CNST namespace. And of course, this should be empty right away because we don't have anything running. But if we kubectl apply, and remember we have 1 replica to start. So all nodes, all pods, all nodes and all zones are viable candidates. So we end up on worker 3, which is of course in zone B. And so no more pods can run on worker 3, but the next pod that we create should also not land on an odd number worker, right? It should land on worker 2 or 4 because they're in a different zone. So let's scale, and we'll just go to 2, right? And that'll give us a chance to see this happen slowly. And so we scale that up, and we see that the second replica is on worker 2. So it's in a separate zone. Now we've got a pod in each zone. So really both zones are treated equally when we continue to scale. So let's do it again and see what happens. So now in this case, we land in the same zone because worker 4 is where the new pod ends up. And of course, that's in the same zone as worker 2, which is our second replica. But that's okay because again, our zones essentially are saturated. But again, we're spreading across our workers. Let's go up to 4. And of course, we should expect that the fourth pod lands on our last unused node. And now we've, of course, created an explicit spread across nodes and across zones. Now here's the catch. What if I scale to 5? Do I just reuse existing nodes? Because I only have a 4-node cluster here in my demo. No, we don't. Matter of fact, replica 5 will stay in a pending state because no nodes can satisfy the required during scheduling expression. And so if I have a situation where there are more pods than there are nodes, then my pod sits in a pending state, which is also why we don't use required during scheduling for zonal-based expressions. Of course, you could if you wanted to, but if I want, of course, more than one pod in a zone, I can't use required, right? I have to use preferred. Well, that is pod anti-affinities and creating explicit spreads. This is just one of the things that you will learn when you attend one of our courses. And you can go to the rxm.com website and check out the custom courseware builder and find the pod scheduling module on our website and add it to a custom course along with a number of other modules. That is our cloud native short take pod scheduling module.